Hello, everybody. So, as we move into kind of just a short little overview of Chapter 11, we're actually just going to dive into Chapter 11, Section 1, an introduction to statistics. We are going to talk about something called the fundamental counting principle, which will lead into permutations and combinations. Now, the fundamental counting principle should have been taught in Algebra 1, which it was, and Algebra 2 assumes that you remember all of it. So what I'm going to do is I'm actually going to take a day to review the fundamental counting principle. Today shouldn't be too awful. I do have some challenging problems, but hopefully nothing too bad for you. So like I said, 11-1 is actually about permutation and combinations. However, we're not ready for that yet because I want to make sure that I review something called the fundamental counting principle with you first. So let's talk about the fundamental counting principles. So for example, let's say you go to a lunch and you have to pick one thing from each of these. So you can have anything from the list for a sandwich. So you could have a list of 4 sandwiches, 3 sides, and 4 desserts. Now, if you want to, pause the video and take a guess as to how many different meals you can come up with. If you pause the video and you tried, maybe you remember from Algebra 1 that you take your options, 4 options, 3 options, and 1, 2, 3, 4 options, and you actually multiply your options together. So 4 times 3 is 12, 12 times 4 is 48 different meals that you can make if you're going to pick one from each list. Now, if you get to pick 2 from each list, now we get into something more difficult, but we're going to start easy. Now, I do have this website here. You will go to 1 minute and 17. I would love for all of you to watch that little video, go to 1 minute 17 and watch it played through. It's about a couple who like predicts what's on a dollar bill. So I'll take a moment and kind of pause, let you pause the video and watch it. It was my hope that you went to that video and that you watched it and that you were able to kind of see it was kind of neat how she was able to guess all of that stuff. Now, at some point in time, the man says it was a 1 in a million chance she got to get the serial number on this dollar bill right. And when I watched this a few years ago, because I used to have time to watch TV, um, but I was like, that's got to be more than 1 in a million. So here's what I did. I actually did the math to figure out what the guess was. Now, this was the serial number that she did end up guessing. I took a little screenshot of it. And he said that it was a 1 in a million chance that she would get the right answer. I want to show you that she actually guessed it was way more difficult than that. So each spot you have the digits 0 through 9. So if you sit there and you count, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when she said 8 right here, she had 10 different numbers that she could have said. When she said 9, she had 10 different numbers she could have said. 10 different numbers for the 7. 10 different numbers. 10 different numbers. 10 different numbers. 10, 10, and then she knew that it ended with an alphabet, so she had 26 letters in the alphabet. So when she said 8, 9, 7, 5, 3, 3, 8, 4A, again, she had digits 0 through 9. 0 through 9 is actually 10 digits to pick from. So if we multiply all that together, let's see, it's going to be a 26 with 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, so let's put our commas in the spots that we've known how to put our commas. Look at that. So she didn't have 1 in a million chance. She had one in where we at? Let's see, this is hundreds, thousands, millions, 2,600,000,000 chance of getting it right. So she had one option out of that many possible options to guess the right combination or maybe the right ordering or the right serial number. Okay? And that is the fundamental counting principle. And so what I did here is when we get to permutations versus combinations, it gets a little more difficult tomorrow when we talk about, well, are we going to do fundamental counting principle? Are we going to do permutation? Are we going to do combination? So the fundamental counting principle are things that you like put together. It's things you put together. So you put together an outfit, you put together a password, you put together a phone number. You have a mixture of different items you're putting together. So you're looking for passwords, PIN numbers, outfits, phone numbers, license plates. They're things that they're identifying items. Like my PIN number identifies myself to get into my bank account. An outfit could potentially identify a thief. A password identifies me to allow me to access my email. My phone number identifies my phone so that you call me. We'll talk about permutation tomorrow. Permutation is like you have like a group of stuff and then you want a specific order. And then combination is you have a group of stuff and you just want a combination of that of what's in that group. Let's talk about fundamental counting principles today though. So let's talk about this motor vehicle. These photos show Maryland license plates from the year 2004, that's this one, and from the year 1912. How many more license plates existed in 2004 than they did in 1912? So what we're going to do is just like when we up here I talked about like the different meals, we're going to talk about the different options when you go to make this particular this particular license plate. So if there are 3 letters and 3 digits, each letter has 26 options. You can pick A, B, C, D, E, F, G, H, I, J, K, L, you know what I mean? 26. This one, you have another 26 options. So for every 26 options for the F, you have 26 options for the second letter. And then for every one of those, you have another 26 options for the third letter. And then on top of that, for whatever you have over here, you have 10 more options for this digit times another 10 for this digit times another 10 for this digit. So if I grab my calculator, I got 26, 26, 26, 10, 10, and 10. So that makes 1,757,6,000. So 17,576,000 license plates in 2004. Now, back in 1912, we didn't need as many license plates, right? So they only did digits. They didn't even do letters. So it was 10, 10, 10, and 10. This is how many different types of license plates. That's 2, 3, 4. There's only 10,000 license plates available in 1912, which makes sense because you didn't need as many, right? So the question said, how many more were there in 2004? So we just take our answer that we got last time, subtract 10,000, and that's how many more license plates there were in 2004. So 1,756,6,000. Let's take a look at the next problem. Well, you're going to keep that calculator pulled up because we're going to need it today. Lots of multiplying. Suppose that you have 33 shirts, 44 pairs of pants. How many outfits do you have? So these are like it's a code to dressing yourself, right? So you take your first thing you need to do, which is put on a shirt. The second thing you need to do is put on a pair of pants. And 33 times 44 is 1,452. In our next problem, we have 15 students that are in a race. First, second, and third places will receive gold, silver, and bronze. How many ways can we hand out the medals to the first, second, and third runners? And there's no ties. So it's like, somebody will get gold, somebody will get silver. So this is kind of like it's very similar to like a password or like there's a specific order and each particular spot is very important. So we have a certain number of people who can win first place. We have a certain number of people who can win second place. And we have a certain number of people who can win third place. So how many people can we hand out the first place medal to? Well, there will be 15 contestants. And then once we hand out the gold, there's only going to be 14 contestants available to get second place. And then once we hand that out, there's only going to be 13 contestants available to get third place. So 15 times 14 times 13 is going to give us 2,730. 2,730. Now, how many ways can we file 12 folders, one after another, in a drawer? So this is kind of like a phone number, a password. There's like some very specific things we're going to be doing in an order. So we have the first folder, the second folder, the third folder, and it does say if we're going to put all the folders away. It's not like we're only going to put away 3 of them. If we were only going to put away 3 folders, we would stop here. But we're going to put away all 12 folders. That's implied in the problem. So, whew, That's going to be first, second, third, fourth, fifth, sixth, seventh, eighth, 9, 10, 11, 12. So when we put the first folder away, how many folders do we have in our hand that we can pick from? 12 of them. Now, when we put the second folder away, how many folders are left in our hands? Well, since we put one away, we only have 11 left. And then we put another one away, we only have 10 left. And then we only have 9 left, 8, 7, and that continues down until we're down to the last folder. Now, if you've ever seen something, that's actually called factorial. If you ever do 12 times 11 times 10 times 8, all the way, that's actually a factorial button. I'm not sure if the calculator lets us use that. So we can type it in little by little like this. Oh, buddy, look at this. Let me just make sure I didn't miss anything. There you go. That's a lot of different ways to put 12 folders away. I mean, I bet if you would have sat there and guessed that you would never have guessed that many different ways to file 12 folders. So let's write the digits down. 479001600. Holy cow. So there's almost half a billion ways to put away 12 different folders. That's nuts. That's the same, by the way, if I had 12 students and I wanted to line them up for a picture, there's it's the same thing. It's like that's how many different ways I can line up 12 students. It's crazy. All right. The next problem is going to get just a little more complicated, and then you guys are going to try some of this on your own. Um, we have a 3-digit number is formed by those digits. No repetitions. Tell how many of these 3-digit numbers will have a number value between 100 and 500. Ooh. Okay, so 3 digits. So it's kind of like a password would be 3 digits, right? It's kind of like a password here. So here's my 3-digit number, right? And these are the digits that I'm allowed to be using, and I'm not allowed to repeat them. How many of these 3-digit numbers will have a value between 100 and 500? Okay, so 100 and 500. So that means this number can be a 1, a 2, a 3, or a 4. Now, if it's between 100 and 500, I guess the argument can be made, could it be 500? I'm going to have to say no, because if it's between those two numbers, I'm going to not, I don't think we're going to be able to include 500. So let's go ahead. So, and I'm only using the digits available to me. So that's 4 different digits I can use for the first number. Now let's say I use one of them. It doesn't limit me at all in the 10 spot. So I could use 1, 2, 3, 4, 5, 6, or 7 for that second spot, couldn't I? Because if I use 1, 2, 3, 4, 5, 6, or 7 for the second spot, that's good. However, how many are, so there's 7 options. However, because I'm going to be using one of them in the first spot, I'm actually down to only 6 options because I used one in the first spot and it says I can't repeat. So I'm down to 6 numbers. And then this last number, because I used one from before, instead of having 7 options, remember the last one got me down to 6 options, this one's going to get me down to 5. So it's 4 times 6 times 5, which is only 120 different numbers. Now, if you want to sit there and form them, we could. Like, it has to be 3 digits and it has to have those. So I could do 123. I could do 124. I could do 125. I could do 126. I could do 127. I could do 132. I could do 134. I could do 135. I could do 136. I could do 137. But the idea is you have to stay between 100 and 500 and only use those digits that are given to us. And while it is kind of crazy, there are exactly 120 different options that I could list. If I kept going with my big long list right here, I would end up with 120 different options. So as you do your homework, you're going to try to figure out, okay, how many options are being presented to me, and then multiply all those options together. And if you need me, just make sure you send me an email before 4 p.m. or join the live Zoom.